All right, we are recording. Happy Thursday, everyone. Today, uh, this week is CSS and SVGs, which I don't think is a super content-heavy week, more so just taking some time to actually go through and add some CSS to your projects. Or maybe that's a homework assignment for a future week. I don't remember exactly. As always, if you have any questions, we can certainly go through those. If there aren't enough questions to get us through the whole hour, then I have a little supplementary topic. We can start talking about TypeScript a little bit. Um, but there's no obligation. Definitely, if you have questions, that's more important.
Can we start with the question?
Yes, we can start with the question.
Oh, my question is like with CSS, is there like a look that we should like a standard look for like websites and apps that we should aim for or no?
Not really. It always comes down to personal style in the end and what you think works and what works for the purposes of the thing you're creating. There's a whole field called user experience, which just does like research on what parts of the website are the most useful, what are people happy about, what do people want to improve, and that generally will play a large role in how you design something. Um, but I think like if it looks good and it works, that's good enough, and you can iterate as you go. There are lots of libraries that can help you sort of bootstrap things, so you don't have to spend quite as much time making it look perfect. Um, I know what my company does is we just use component libraries, rather than having like dedicated front end people. Um, so we'd use something like Material UI, I think is one of the most common ones. And it's just a library that gives you a bunch of pre-styled React components that you can just kind of throw in your website. And typically, you can kind of tell when a website is using specific component libraries if you've used that component library before, because these things look very similar. Maybe you tailor it a little bit, but the actual component itself looks very similar. Um, I think it's based on like a material design standard that's created by Google. Uh, which, if you wanted to follow some various kinds of design standards, you could do that. Um, but no, I think in general, like pick what works for you and go with it until you have a reason to make something more perfect or more templatey. Um, Question from Jenny, do we need to do Tailwind? Um, Tailwind is another CSS library that can help you out. It's a library that allows you to write CSS directly inside of your HTML tags in shorthands. So these are all classes that you're applying to an image that Tailwind has defined to have very specific CSS uh, properties that go with it. So I can apply the W24 property to anything, and it'll set the width to be 24 pixels or whatever. So like the theory here is that you're writing really shorthand and you're writing it right with your layouts. So it's very clear, like you don't have to go and try and track down in a bunch of different locations, uh, a bunch of different styles that sort of merge together to style this component. There's pros and cons here. Some days I love it, some days I hate it. I've used it a little bit before. Um, but you certainly don't need to use it. If you're interested in trying it out, I would highly suggest you do so. Um, but certainly it's not a requirement. It's not like the thing that everyone uses. They do two different things. So Tailwind is specifically to help you write CSS faster. There's other tools that do the same thing. There's like something called SCSS, which is a preprocessor that allows you to write CSS a little bit more flexibly and a little bit of shorthand, um, which you could use that if you want to. It kind of does the same thing as Tailwind, where it's uh, sort of extending the capabilities of vanilla CSS. Whereas Material UI, like literally, you're inserting it directly into your React app. So this isn't Material UI is not like some way of writing CSS for a component that you write. Literally, it's a complete React component that's pre-styled, has all the functionality you need, and you just stick it right in your website and then hook into it. And there's other things like Material UI as well. Um, like there's literally, I think Bootstrap. Uh, this is also a component library um, where you can sort of restyle things according to a standard. These are just ways to get you going faster so you don't have to spend as much time actually worrying about what it looks like. Whereas something like Tailwind is to help you figure out what it looks like, but not have to write as much CSS or write it a little smarter. All right, and then let me get back to Anuha's question. Do we need to clone and fork the repo every time? I'm not sure which repo you're talking about necessarily. I assume you mean the repo for the legacy React homework that was last week.
I'm talking about the whole repo, like the first question from the genie, like she fork and clone it down to the local computer because I cloned and forked down the original repo only once.
Yeah,
After that, I just created the pull request and merged the pull request
yeah,
and
that's all
working
you
on
have
the
to do.
different branches. That's what I'm right now doing.
Yeah, you can only fork it once. I think probably Jenny is talking about the legacy React homework, which was a separate repo that you had to fork again.
Okay.
I don't know if it's 1.9. I think it is 1.9. I think this CSS is 2.1 or something.
Okay. Okay. And one more question I'm
Mhm.
having. Actually, like 2 days back, I had one assessment related to one opportunity, and it was like related to only CSS, and it was like very detailed concepts of CSS. So, how depth knowledge of CSS we need? Because generally, whenever do the projects, I use Bootstrap and Tailwind ready components, and or the external css file for little bit of styling purpose, but not that much of css part. But that is also like a very basic things, but that day it was like super complicated css assessment, and only every question has only like 60 seconds to complete, otherwise it is marks as a wrong answer.
I think in general, you want to be comfortable with anything that you need to work on. Um, like this just goes for software engineering in general. Like generally, we don't want to accept things as magic. Um, and just like, oh, it works this one time, so I'm just gonna not think about it too hard because eventually it will come back and you'll have some small little problem and you need to like really know what you're doing uh in order to fix that problem. And styling goes the same way. In general, using a component library like Bootstrap or like Material UI is very, very common. Like in that case, you don't need to know exactly what the CSS is doing as long as it looks good, but you might want to tailor some of the stuff that it applies to your components, in which case having knowledge of how the internals work and the CSS properties that you need to change in order to make the thing look even better, um, then that's pretty important. And also, you won't be able to use a Material UI or a Bootstrap or a Tailwind for everything. There'll be some things like a component that you create by yourself because there is no such component in the library you're using where you are going to have to style it yourself. And so being comfortable to say, I want this to align in this particular part of the screen, and it should do this thing. Like maybe it's not supposed to be on the same line as all the other content. Well, how do I do that? Well, maybe I need to change the display property, something like that. I think in general, you don't need to be able to just like rapid fire how to do things, but you should generally know the most common properties so that it doesn't feel like magic and you can try some stuff out. Learning design and styling. Um, I don't know. I think all you can really do is just practice in the context of making something that looks cool. Whether that be like a project you're working on and you have a specific vision and you don't know how to do it yet, but you kind of work through it in steps, or um, or just like come up with some cool stuff that you could do, and maybe it'll come back in the future, and you'll actually need to do something similar to what you've done, and then you have something to draw on. I have gone through phases of my life where I create code pens. CodePen is a website that's been around for a little while that just allows you to create little snippets of HTML, CSS, and JavaScript that do some cool stuff. Um, Mine are not particularly exciting, but I do come back to it every once in a while because it's a good like testing ground for cool stuff, but also it's just kind of like a sandbox if you want to make something cool. People here have like all kinds of crazy shit that I could never, ever, ever even begin to make. So definitely don't feel intimidated, but maybe you see something cool on here and you want to learn how it works. And so you can go in and see this thing that someone has created, and all the CSS properties and how they did a really cool effect, um, stuff like that. This one's a little complicated. The stuff that I've worked on is generally much smaller. Uh, Sometimes I like fork something that someone else has created and then make it myself. Um, I made a sandbox of different kinds of buttons that do different things. It's really just a sandbox and you can try out some cool stuff. Maybe you see an effect on a website that you really like, but you don't know how it works. You can just put together a little sandbox and play around with it until you get it right. But again, it's like other software. You don't have to just know how to do everything perfectly off the top of your head. You need to know what the properties do so that you can experiment or find help online and it makes sense. Did the front-end developer learn design with Adobe or another design system? Be professional. Um, it's a good question. I don't know the answer to this necessarily because I don't actually work in the space. I would say in general, if you're going to be a front-end developer, you should be comfortable with um, understanding important concepts about UI and UX, like how to make a design that's accessible for people that are using a screen reader because they're blind or have some sort of other disability. Um, that's something that's pretty common. Maybe you want to be careful about your color palette and make sure that you're following sort of color theory, color rules, and not using too much of a particular color or too many colors or stuff like that. Just sort of general concepts. And like UI, UX research is generally a separate job, I think. So Like, you don't have to be perfect at anything ever. Um, you don't have to know everything. That comes with time. But being able to take something and implement it, I think that's the most important part for if you're going to work uh, as a front-end developer. And then someone else can give you the requirements, your UI UX researcher, your project manager, stuff like that. And you just need to be able to put it in practice. Any other questions? Is there a resource to provide free React page templates? I would bet there is. Um, I've never looked for any explicitly, but I'm sure that you can find some. These ones are on Material UI, and so I think they probably use a lot of Material UI components. Um, you'll notice that some of these things look very similar, like all these little white boxes on the gray background. These are probably Material UI components. This bar at the top, stuff like that. I think in general, you can find like basic HTML templates pretty easily. I know I've done this in the past. Um, React templates are a little different probably because like HTML is literally just the elements on the page and it doesn't do anything. And so you change the elements on the page. If you need it to do some stuff, you write a little bit of JavaScript. Whereas React, like it's all the JavaScript that makes it happen. And so I think you'll be a little bit harder pressed to find like complete templates for a React app. And you'd be more likely to find little components that you can just stick onto your site that are isolated and have functionality and styling attached to them. Um, and stuff like that. That would be my guess. I would say that if you're not using some sort of CSS library or you're not using a component library, you're going to be styling from scratch. Um, just so that you have full control over how everything looks and how it's all oriented. Um, trying to think if there would be any caveats. I think it's pretty common that you'd be writing the CSS that's important to you, unless you're using a library of some kind. An example when you need to use the global prefix for styling. I am not sure about this one, to be honest. CSS modules, target selectors, created outside. Description. think this is specific to CSS modules. Uh, hmm. All right. I'm gonna have to do some personal research on this and get back to you to answer this question. I'm gonna link this temporarily. I think this is close-ish explanation, although more specific details I'd have to follow up later. Sorry, I can't answer that. All right, any other questions? Okay. So, seeing no further immediate questions, I want to transition for the second half of this class to just kind of briefly talking about TypeScript and why you might be interested in it. So what I'm going to do is I'm going to let's do this. We're going to feat, or no, npm create feat at latest Node.js React project. We'll make this a React project with vanilla JavaScript. And open VS Code and install everything and npm run dev. Oops. Let's open my folder this time. All right. So the way we've been doing this before, if I wanted to create a React component, we'll create a table.jsx. I'm going to declare this like any other component where I declare a function, and the name of my function is going to be React table. Yes, we're going to do that in a second. And I'm going to get my props, and I'm going to return a table element and my table rows. And actually I have to do my table body first, and then I can do my table rows of content, so on and so forth. So let's pretend that I have a bunch of properties that I'm passing in here, and I'm going to use this table component from my app. So we'll use our table, cool table, which I need to export down here. Export default app. And we'll use my cool table. And we're going to pass it some properties. Foo equals bar. Hello equals a function that prints hello world. And we'll give it a number property. That's going to be equal to 3. Cool. So these are 3 properties I'm passing to my table over here. However, when we have a props object like this, JavaScript doesn't give us any kind of validation about what's actually in this properties object. You can use your prop types down here, like you can install the prop types package. And then you can do your validation and say, well, I have this property foo, which needs to be a string, so on and so forth. This isn't the real syntax. I've never actually used prop types myself. But this only helps you once you actually run your application. It doesn't help you as you're writing your code. When I run my code, prop types will tell you in your console, the console of your page, that you're breaking your prop types over here. But it's not actually going to tell you as you're writing your code. And so you could get very far along into your project, and you don't even know that your code doesn't work until you've already finished your feature. And then you're trying to test and make sure it works. And now you have a bunch of little bugs that you can't really figure out what's going on. So the reason why I would use TypeScript is these little data types and functions. JavaScript doesn't give you any validation as you're actually writing your own code that you're doing things correctly. I could do anything I want here. I could try and log props dot. It's not going to give me any sort of autocomplete because it doesn't know what could possibly be in there. Maybe I know that foo is going to be in there, and maybe I think, well, if there's props.foo, then there needs to be props.bar as well. But if I run this, it's going to print out bar when I get props.foo because that exists. That's the thing I passed. But props.bar is undefined. And so if I were expecting this to be defined and I tried to call something else on it, or maybe I thought this was going to be an array, so I was getting an element of this array, then I refreshed my page, then it's going to tell me that props.bar is undefined. So I can't get this first element of that thing. So we're running into all these type errors that are happening at runtime when our code is actually running somewhere. And we want to catch these really dumb, stupid mistakes of, well, I didn't have the right type of value. I want to catch it early. I want to catch it as I'm writing the code so that I don't like write myself a big bug that I don't find until later. So that's the problem statement. The solution is creating a React app with TypeScript, or in general, anytime you're using JavaScript, I would say it's probably better to use TypeScript if you're comfortable with it. So what we're going to do instead is we're going to remove this project we just created, and I'm going to npm create vt at latest. And we'll call this demo TypeScript React project. And this is a React app, and we're going to select using TypeScript this time. And it's going to do all the hard work of setting up TypeScript for us. We'll look at the installation in just a second. And all the different components, which generally, if you're starting from a non-TypeScript project, it's a little harder to figure out what you need to install and what you need to set up in order to make the TypeScript work. But Vite just does all of it for you. So you might as well. Okay, so this is our new project. You'll notice one thing that's different is instead of .jsx, all of our files are .tsx. If I want to write just a normal JavaScript file that's TypeScript instead, then I can write normal file.ts, which is usually going to change the icon in your editor, rather than .js. JS is not going to give us any kind of validation, but TypeScript, that's going to give us our validation. You notice some other things that it threw in here. It threw in this vite.env.d.ts. This is just for Vite. You don't probably need to change this at all. Files that end in .d.ts are type declarations, which take regular JavaScript code and just add types to it. And then you can use that code with the types in your TypeScript. In general, if you're writing TypeScript, you want to be working with libraries that have types for their code, because people will write JavaScript libraries and there's no types defined because that's not a thing in JavaScript. And so people will write type declaration files that sort of just are like a mask to the actual library and add specific types to all of the data and all of the functions so that when you use a TypeScript, TypeScript knows what to expect and can help you. .tsx is for React files. So anything that has your JSX, which is the stuff that gets returned out of your component, needs to be a .tsx file. A .ts file is just normal JavaScript code, no React stuff. You probably won't be creating a whole lot of these unless you're creating like a file with helper functions or stuff like that. But your components will all be .tsx. If I'm looking at this, I'm not really seeing anything different compared to a regular JavaScript project. I could probably right now rename this to be app.jsx instead of .tsx, and I don't think that anything would break. Yeah, it all still works. So right now, there's nothing in here that's taking advantage of our TypeScript necessarily, but we're going to get there for a second. .ts is when you're just writing vanilla JavaScript. So if I'm writing functions, if I'm writing classes, or if I'm writing, we haven't talked about the actual functionality of TypeScript yet, but eventually you'll be declaring your own types. Like it's one thing to say, well, I am writing this function and I want all my parameters to be integers. In JavaScript, I would just write param1, param2, and we'd have no idea what these types are. But TypeScript doesn't let you do that. It makes you explicitly give a type to everything. And so I can give it a number type. But you'll also be writing your own types that are more complicated for like if you have an object, which is very common if you're getting data from a server, well, that data has a format. And so that format is a type that you'll be declaring yourself. And that also would probably go in regular .ts files. Anything that is a React component that returns JSX needs to be in a .tsx. If there's no JSX, then it's in .ts instead. Okay, let's look at some other stuff. Most of this is similar to your regular Vite setup. This is also just sort of properties for ESLint, which is the plugin that's installed that goes through all of your JavaScript and makes sure it's valid. It's using a TypeScript parser here instead of just regular JavaScript. So there's a little bit of changes in here, but generally you won't really notice anything. You will notice that there's two files down here, which are tsconfigs. So tsconfig is a file that declares all the rules that TypeScript is going to try and enforce on you. So you can identify like what language version of TypeScript you want to enforce. or what you want to compile it to, because in the end, TypeScript is just a superset of JavaScript, where anything that's valid JavaScript is valid TypeScript, but TypeScript also allows you to just add annotations to all of your data to identify what type it is. But in the end, those annotations are not valid JavaScript, and so it's going to have to compile back into regular JavaScript. So you can declare what is it going to try and compile into. There's all these other rules. These ones down here are your linting rules. So this is like the actual rules that TypeScript is going to enforce on you. Strict means I can't just like not type my things. If I don't apply a type to it, it's going to freak out. If I turn this to false, then I could not apply types to everything, and it would just be like writing normal JavaScript, but it would let me do it. So generally, this is something that you would want to turn on, although there's some rules that are more like personal preference, and so those you can disable. And then there's these other things. This is just a lot of configuration that V has done mostly for you. If you have specific things that you know you want to change, then certainly go in and change them. And eventually you'll come across errors. It's like things that don't work. And Stack Overflow will tell you to change something in your TS config, in which case go for it. But otherwise, once you get a working config, you generally don't have to touch it again. Okay, so we looked at all these configuration files, but we didn't even talk about what TypeScript is yet. So let's go back to the example where I'm creating a separate component, a cool table, TSX, and I'm going to create function my cool table, and I have a props object. So you'll notice right away that before I can even start writing my function, it's going to hover over here and tell me that this property object has an any type. Any means I did not apply a type, and so it could literally be anything, and it cannot help you identify what's going to be in there. If there are properties on this object, like what type are they going to be? What's the value? Who knows? And so we want to avoid this. TypeScript allows you to explicitly say when you have data that needs to be of a specific format. So I could say that this thing up here is a number. And then inside of my code, well, now I can treat this properties object as if it's a number, 1, 2, 3, 4, 5, whatever. And I could do return 1 plus props. Since it's a number, I know that I'm allowed to add it to another number. Ignore this. This is not a React component. Actually, we're going to put this in just another file really quick so that we don't confuse it with React stuff. Cool. So we have this function. It takes in a parameter, which is a number, and we can add it to another. I could also give this another type. I could say this is a Boolean. Well, in this case, now JavaScript or TypeScript is yelling at me that I cannot add a number and a Boolean together. Let's do the same thing in a .js file. And we're going to split screen this so that you can see the difference between TypeScript and JavaScript. Function my func1 and some random parameter. In JavaScript, I can't give this an annotation or anything. If I try and do this, it's going to tell me it's not valid JavaScript, and it's going to say, you doofus, use TypeScript instead. So I have to give it no type, which means it could be anything. And I could return 1 plus param, and it's going to think it's totally fine. Now I could call my func1 and give it a string, or I could call my func1 and give it a Boolean, or I could call my func1 and give it an array, so on and so forth. And JavaScript is not going to complain about any of these because it doesn't know. TypeScript, on the other hand, is telling me, well, your parameter you said is a Boolean, so you can't use it like a number. And there's no possibility that we're going to write code in this case that just inherently doesn't work. You are telling the compiler, this data has to be this type. And everywhere I pass in the data, it has to be this type. And so you're eliminating just so many bugs in your code from declaring a piece of data and then accidentally giving it the wrong value, or maybe writing something that's a little bit wrong. Maybe you forgot like one or two characters and it turns into something completely different. It can't happen. You can't do that. And so anytime I call my function in a TypeScript file, it's going to scream at me unless I give it a Boolean. So I know as I'm writing my code, oops, I did something wrong. Let me go fix it. And this all works. So this is why we use TypeScript. This is like a very basic case. You can also say that my function has to return a Boolean. Like anytime you annotate a piece of data or a function, you use a colon and then the type that it represents. So this is the return type. This is the type of this parameter. And so now my func, if I hover over it, it's going to tell me, well, the parameter is a Boolean, the return is a Boolean, and I cannot add this Boolean and a number because they're not the same type. Whereas in normal JavaScript, I could take any of the results of these and add them to a number, or I could get a string and add it together, anything like that. So let's run this really quick. So you can see the difference. I'm going to run this with Node. And I'm going to run source/normal file.js. Interesting. Would have expected that to give me an error. Cool. So this over here is going to give me 11H 11 hello. And this one down here is going to just give me 1. And then this one down here is also going to give me 1. But this one is a string and this one's a number. If you think about it, none of these should work. It doesn't make any sense. I wrote this function with the intention of adding two numbers together, and none of these have actually done that. Whereas over here, if I know that this is a function that needs to add numbers together, then it is impossible for me to write any code that doesn't work. And I can run TypeScript compile. I think I'm actually set up to do this. Yeah. I would need to install TypeScript compile globally in order to run this explicitly. But in general, if there's no squigglies, then I know it's going to work. I can also run this in the TypeScript playground, but we don't have a whole lot of time, so I'm not going to do that quite yet. There's other cool things we can do in TypeScript. Let's say that I make a fetch request to a server. Maybe you're making a request to Airtable, and I get a promise back with my response. I call await res.json. And then I call .then, and now I have my data. Cool. Well, in JavaScript, this data is any. I know in theory what I'm getting back from my server, but I can't be certain that it's going to look exactly like I expect. And even if I know what I should be getting and what properties those objects are going to have, my code doesn't know that, and so it can't help me out. And it's really stupid. Yeah, I'll share the link at the end, right before we leave. So it's telling me that this data is declared but not used, and I could call data.get thing and pretend there's a method on here, or I could call data.first name or data.last name, so on and so forth. Well, I know that the data I'm getting back from here is a user. Maybe we're getting user number 1, or the user with ID number 1. Well, I know that my server returns user data, so I'm going to declare an object type that structures the object that I have, the JavaScript object and all the different properties. And so I can use this as a type where my type is user, and it's equal to, maybe they have a first name, which is a string, and a last name, which is a string. I have a birth date, which is also a string. And then they probably have an address. Maybe this address is another type. Actually, lowercase this just to differentiate. And this address has a street, which is a string, and it has a city, which is a string, state, which is a string, and a zip code, which is a number, and so on and so forth. I could make this more complete. I'm trying to think if there's anything really bad that I missed, but I can't think of anything. And so I'm declaring types for these objects that I know I'm going to get back and the structure that they need to be. And now I can annotate my data as a user. And I can't call get thing on this user because this isn't a method that exists. I can get the first name and the last name because I know those are properties I'm supposed to get. But I can't call data.age because that's not a property that exists. And so again, we're telling our compiler what we're allowed to do with this object so that we don't make any mistakes as we're writing our code and trying to do something that doesn't exist. And you might say, in some cases, when I get data back, it's not actually going to be this, it's going to be something else. Like maybe this address doesn't exist. Maybe they haven't given us an address. Well, I can tell TypeScript that this can actually be an address or it can be undefined using this question mark, which means I can give it either an address type or I can give it undefined, but nothing else. So if I say let my address equal to an object, then this object, if I give it the address type, it's going to complain because it's missing these properties. So let's add those properties. Street equals some street, and city is Chicago, state is Illinois, zip code is 12345. And I could also say let or my address is equal to undefined to indicate that there is no data there right now. Oops. I can't use the question mark up here. That's only for properties down here. So let's say user equal to a user first name, Eli, last name, Smith, states, birth date is March 16th, 2001. And then I have to give it an address. Well, I can give it my address, which is this object I just created. And this is okay. I'm getting these squiggles, but they're not actually bad. They're just saying I'm not really using this code, which I'm not. I'm just proving a point more than anything. Or I can say my user dot address is equal to undefined. So this is also fine. Maybe I don't have a value originally, and so I leave it as undefined, or I don't even declare it. That's also fine. It'll make it undefined by default. And then I declare my address later once I pull that data from somewhere else. So you can do really cool stuff like sometimes it has data, sometimes it doesn't. But you need to explicitly tell the compiler that in this case, it's okay for there not to be data there. And then everywhere else you try and use that, it's going to force you to account for the fact that there might not be data there, which is actually a good thing. If there's a possibility of there not being data and you write some code somewhere that assumes that the data is there, eventually you're going to run into an exception where you're trying to get a property of a null object or something like that. Happens a lot. And in TypeScript, you really can't do that at all because you're guaranteed to think about whether that could be null or not. And unless you say that it can be null, you can't make it null. So this data is of type user. I can't set data is equal to null. That is not valid. So you're eliminating whole classes of common errors by using TypeScript. And all it really forces you to do is just add type annotations to things. You don't have to do anything more complicated than that and maybe declare some types for your objects. That's honestly the most that I've used TypeScript for. But the validations that it gives you are so useful that to a degree, I don't know why you wouldn't use TypeScript once you get comfortable with it. Yes, the question mark means optional. So the question mark is my property here. It's a string, or it can be nothing, an address, or it can be undefined. If you hover over, it's always going to tell you what this type is. This bar is a union, which means it can be one or the other. So we saw earlier that if I declare a type, or if I declare a variable, I can't use the question mark here to say, well, it might also not be a number. That's not valid. But I can use a pipe, which is a union, to say it's either a number or it's null. And now this is fine. And it's just saying I haven't used the value. You're not going to spend a whole lot of time defining types. Like these object types, you're going to define once and then you're just going to use them. And you're only going to define them when you need them. So it's not like you're going to spend a bunch of time, ooh, I need to go and think through my whole website. You're just going to declare them once you find a need for them, like when you're getting data back from your server. And you can reuse them too. Like I'm going to declare my user type in a separate file. And then everywhere I make a call to my API, I can use that same user type. I don't have to redeclare it everywhere. And that might be from several different places in your app. Yes, in general, you do need to. TypeScript does help you out though. So up here, I didn't declare a type for this ID property. but it's not going to let me put a string into here. Oh no, it's because it's a constant. But if I declare this, it's going to automatically detect the type based on the type of the value I'm giving it to. So you don't have to declare type on literally everything. A lot of times it will infer it for you. And then you still get the benefit of, well, I can't put a string where I expect a number. But in the case of like a parameter to a function, the compiler has no idea what you're actually going to call this with. And so here's where you have to explicitly say this is a number. And then inside here, 1 plus param1 other num. The only types I had to declare are this parameter and the return type. This is just telling me I'm not using this function yet. And then this other num, this is telling me to use a constant. If I look at this, this is a number type. It's inferring I'm adding a number plus a number, and so I don't have to type this if I want to. And most of the time, you'll be writing code where you don't have to type it. You just have to type the parameters of your functions. And then if you have any like objects, data types, you'll be writing types for those. But again, this is a good thing. You should be doing this. You should not just be getting some stuff from the API and then making random assertions on it. If you're using another library, those libraries will typically have types for you. There's a thing called definitely typed, which is just like an open source project that goes and gets all the most common libraries and declares types on JavaScript libraries that are just basic and don't have them yet. And so if you're using a library, generally they will have all the types for you. Code that you're writing, you will either have to declare the type yourself or it will infer it automatically. But I don't know if there's any tools that can like go through your code and automatically throw in the types for you. Oops. All right, any other questions? We're at overtime, so I don't want to take up any more of your time. All right, thanks for coming, everyone. Make sure to fill out your attendance, please. And I'll upload this as soon as possible. I forgot who asked, it might have been Sonali. The links to my recordings are always in the mentor session dashboard. Come on. CTD learns recordings. So I don't know exactly where this is linked or where I found it. It might be in the Grackle announcements channel, but I'll put it in the agenda for today. All of my sessions are recorded and I upload them within a couple days. So you'll notice that they go back from February when we got started. And there's some other stuff in here from other classes too, from intro and from the node classes. But I try and keep up to date as much as possible. So they're always in here. And I just put them all on the same YouTube channel. So you can always just go to my YouTube channel directly and that also works. Cool. All right. All right. Thanks everyone for bearing with me. We'll catch up next week. Good luck and have a good weekend.
Thank you.